We're going to learn about first-degree equations, also known as linear equations. First, let's establish what are equations. Equations, they are made up of two parts or two sides, left-hand side, right-hand side, and the left-hand side is equal to the right-hand side. And this is equal sign. So this is an equation. Now, on the left and on the right, there could be anything. There could be numbers like 20 on the left hand side, and on the right hand side also numbers like 19 plus 1. So you can see 19 plus 1 is 20. They're equal. This is an equation. Sometimes equations contain unknowns. I'm assuming you watched the episode about the unknowns in algebra. So essentially, equations, they're similar to old-fashioned scales. So they're made up of a hanger and a bar at each end of the bar. There are like chains that there are two balls connected to them, something like that. So they have to be always equal, left hand side to the right hand side, meaning if you put one brick here, you have to put the same mass on the left hand side so that this is always horizontal, right? This is always left and right are equal. This is an equation. An equation is like an old-fashioned scale. So as I said, sometimes equations contain unknowns. Look at this one. The left hand side is 2 times x plus 1. The right hand side is 20. Right? So this one contains some unknowns. So we want to learn how to solve linear equations or first degree equations. This is a linear equation or first degree equation. What does that mean, first degree? Why we call it first degree or why we call it linear? Because the exponent of the unknown, the largest exponent of the unknown is 1. When we don't write the exponent, that is 1. So we don't see in this equation, we don't see a single unknown that has an exponent larger than 1. That's why we call it first degree, right? So if it has the largest exponent of the unknown in the equation was 2, that will be a second degree equation. Right now is 1, so that's a first degree equation. Now that we established these terminologies, let's learn how to solve linear equations. Look at this equation. Let's say 2x plus 2 equals 20. Okay, so what do we mean by solving this equation? We mean finding what the unknown is. The unknown here is x. We don't know what x is. You can replace x with a blank space, right? I could write this equation like this. 2 times, I don't know, 2 times blank plus 2 equals 20, right? It will be the same. Or we could write it like this. 2 times question mark plus 2 equals 20, right? So this question mark is basically something, some value, some number that we don't know. We want to find out what it is. And this equation is our clue to its value. So we're going to, just for simplicity, we call it x. We give it a letter, English letter. So don't get scared of when you see x. It's nothing. It's just like a puzzle. It's like a question mark. So let's see how we can find the value of x or solve this equation. Sometimes they call it solve for x. Find x. What is x? Solve this equation. These are all the types of all the ways that they ask you to solve an equation. Okay, so When we want to find x, basically we want to eventually reach to a situation where we have on the left hand side or on the right hand side, doesn't matter. On one side we have the unknown x, and on the other side we have the numbers, the number that it equals to x. So we have to manipulate this equation in a way that we convert it into x equals something. So how do we manipulate it? Again, let's think about the scale, old-fashioned scale problem. Well, my drawing is getting worse. So if suppose you have like some stuff here on the left hand side and you must have equal amount on the left hand side. If you change the right hand side, for example, if you eliminate one of these, you have to do the same on the left hand side so that the balance is maintained. Otherwise, the scale will collapse or will be tilted on one side that is heavier than the other side. But because we have an equation, equal sign equation, we maintain the balance always, we maintain the balance. The scale has to always be horizontal. So what do I mean by that? I mean, if we are supposed to manipulate this equation in a way to get into this format, when we're manipulating this original equation in the white box, we have to be careful. Whatever we do to the left hand side, we have to do to the right hand side. Okay. On the left hand side, I have 2 times x. This is one term, 2 times x. And the other term is 2. On the right hand side, I have one term only, that is 20. Okay. So, first of all, to get to the x equals something in the like this, to solve x, I need to isolate x on one side, right? I need to isolate x. So I need to declutter anything that is on the left hand side so that I can isolate x. So let's do something. I have this 2 in here, right? This 2. This is bothering us. This is not allowing to have x as isolated. So let's eliminate it. How? Well, we can subtract both sides of the equation by 2. So I say 2x plus 2. So far, that's the left-hand side. I subtract 2 from the left-hand side. Equals 20. Am I done? No. I have to do the same thing I did to the left-hand side to the right-hand side as well. So 20 minus 2. Otherwise, the equation is disturbed. The balance is not maintained. So to maintain the balance, we do the same thing that we did to the left-hand side, we do to the right-hand side. Okay, now let's simplify things. The left-hand side is 2x plus 2 minus 2. So plus 2 minus 2, what's the result of that? 2 minus 2, that's 0, so nothing. That basically eliminates, that will be just 0. So 2x plus 0, that's it, equals 20 minus 2, what is that? 20 minus 2, 19, 18. So 18 is the result of right hand side. Okay. So 2x plus 0, 0 is nothing. 2x plus nothing is just 2x. So I can rewrite this equation just as simplified as 2x equals 18. Nice. So you see on the left hand side, the original equation, we had 2x plus 2. The operation that I performed, I subtracted 2 from both sides. I did the opposite, right? It was plus 2, I subtracted 2. We're step by step isolating x. Another thing that is still bothering us is this multiplication by 2. Is 2 times x equals 18, right? So this needs to be eliminated now. How do we do that? 2 times x. So how about we divide both sides of the equation by 2? How about that? I can in that way eliminate this 2 and further isolate x. So we will have 2x divided by 2 equals. Now I have to do the same thing to the right hand side. 18 divided by 2. Cool. Now let's see what we get. 2x divided by 2. 2 divided by 2, that's just 1. Right? So on the left hand side it becomes 1x equals. Now right hand side. 18 divided by 2. What's the result of that? 18 divided by 2 is 9. That's it. 1 times x equals 9. What is 1 times x? Well, 1 multiplied by anything is just any non-zero number is itself. So 1 times 2 is 2. 1 times 3 is 3. 1 times x is x. So basically x equals 9. That's it. We solved the equation, meaning we solved x. We found what x is. So in this original equation, if you substitute x as 9, you will see the left hand side will be equal to the right hand side. That's how we solve this kind of equations. So the goal is to isolate x, and step by step, whatever is cluttering things up, you eliminate them. Let's see another example. Suppose you have 3x plus 4 equals x plus 16. Okay. Again, an equation. So in here we have the left hand side 3x plus 4, right hand side x plus 16. And we know that we want to convert this into a situation where we have just the unknown on one side, x equals a number. We want to manipulate this in a way to get to x equals something so that we can find the value of x. We can see through x. Again, operation by operation, we try to isolate x. So you notice here we have two terms that they contain the unknown. One is in the left hand side, one is in the right hand side. So what should we do? Well, easy. We can just put all the unknowns on one side. Let's keep all the unknowns on one side. So for example, I can subtract both sides by x. So let me actually color code it so it's easier to understand. I'm going to subtract both sides by x. So the left hand side is 3x plus 4. I'm going to subtract an x from it equals the right hand side is x plus 16. I'm going to subtract x, choosing green, x from it. Why did I do that? So that the x on the right hand side gets cancelled. You will see in a second. So let's do the right hand side first. We have x plus 16 minus x, right? X plus 16 minus x. I can write it as x minus x plus 16, right? I just moved this one closer to x. We can move terms in an equation, no problem. So x minus x plus x 16. Something minus itself is 0, like 2 minus 2 is 0. X minus x is also 0. So the right hand side is just 16. Simplifies as 16. The left hand side, 3x plus 4 minus x. Again, we combine terms here. We combine similar terms. So the terms that they contain the unknown is 3x and minus x, right? So they can be combined. That's why we can write them besides each other, like 3x minus x plus 4. So the terms that are of the same nature are the ones that they contain the unknowns. So 3x minus x, that is just 2x, right? 3 apples minus 1 apple, that's 2 apples. That's how it works. So basically let me write this a bit down. The right hand side is 16, the left hand side is 2x plus 4. Okay, now again we have things of two different natures. One is this 2x that contains the unknown, this term 2x, and we have other types of terms, the numbers. They don't have unknown, they don't contain unknown, so they are one nature, like apples and oranges. We cannot combine them. So we want to isolate x. Again, that's our end goal, isolate x on one side. So how about I subtract both sides of this equation by 4. Again, let's use a color, for example, red. Subtract 4 from both sides so that we can eliminate this 4 on the left hand side. So 2x plus 4, now minus 4, equals 16 minus 4. Again, the left hand side, 4 minus 4, simplifies as 0. 4 minus 4 is 0. 16 minus 4 is 12. So I'm gonna go write it here. The left hand side becomes 2x plus 0, which plus 0 we can just not write it because anything plus nothing is just itself. 2x equals 12. Now in the final step we have 2 multiplies x equals 12. We still have an isolated x. So next we can divide both sides by 2 to get rid of this multiplication of x. So I said 2x divided by 2 equals 12 divided by 2. So 2 divided by 2, 2 divided by 2, that's just 1. 12 divided by 2, that's 6. So x equals 6. That's how we isolated it. Step by step, we isolated x, doing every operations that would achieve that goal. Okay, so hope you enjoyed it. Let me know if you have any questions or comments.